Food is expensive. All right. All right. Let's get started, y'all. It's time. It's time. So here's your exam from last time. Let's take a brief look at our formulas, right? This is the formula from the last section. This is the formula for the new section. They're related, right? Okay, this is if you have an annuity and you're making payments and each month you collect interest on that payment, and this tells you how much you'll have after a certain number of payments. This is if you, let's see, you start off with a certain amount, that's your present amount. So you put a bunch of money in the bank, say, and then each month you take a little bit out, but you're still earning interest on that money that's still in there, right? Eventually you run out of money, right? But this tells you how much you will get. Say if it's monthly, how much you'll get a month. Like if you put like $15,000 in the bank at a certain interest rate, but every month you take out a certain amount, right? This tells you the amount that you'll get over a certain number of periods. So here's your exam. Number one, how much should you deposit in an account? So that would be a present value. How much would the present value need to be if it's paying 8% quarterly in order to receive quarterly payments of $1,000 for the next 4 years? Okay, so this is one of those present value formulas. It's this one right here. It's the present value of an ordinary annuity. So your present value is your PMT. Let's see if I can remember it. Is it 1 plus I to the minus, no, this one's negative. 1 minus that over I. I think that's right. Yeah. Remember, compare this to what we had last time. They're really close to the same, but they're different things, right? Again, this one is if you're putting money payments over and over again, and you're collecting interest on that, how much that'll be worth at a future time, so your future value. This one is you put money in the bank, your present value, and then every month, every quarter, or whatever, you're taking out a payment. You're taking money out of that investment. Okay, but you're still earning interest up in there. Okay, so that's how these things are related. So this one here is asking you how much money do you need to put in the bank at the present if you're going to take out a payment of $1,000 and until you run out of money in 4 years. So we need to know what I is. What was it? It's your rate per period. Rate per period. The rate is 8%. There's 4 periods a year. And we need to know what N is. Well, N is the total number of periods. So it's the periods per year times the number of years. So if N is 4 and T is 4, then N is 16. The present value is, well, we have $1,000 payments coming to us. And let's see, I is 0.08 divided by 4. And this is to the negative 16th power all over I. At this point, you plug it into your calculator. And I think I did that last time. Let's see what I got. Plug that in your calculator. You should get $13,577.71. Questions? All right, let's look at number 2. Monthly payments, all right, of this much, 245, are made for 4 years to repay a loan at 7.2% compounded monthly. All right, since they're monthly payments and compounded monthly, that means that M is 4, and we're going for 4 years, so T is 4. We want to find out what I and N are. Well, I is your rate per period. Let's see, our rate here is 0.072, and M is 4. So if we plug that into our calculator, I think we get 0.006. I think, let's see. Yeah, 0.006. So that's what I is. We need what N is. Okay, well, N is the total number of periods. So it's the periods per year times the number of years. M is 4, T is 4, so N is 16. This one, you don't even have to use the formula. They're just asking you to figure out what the variables are, basically, that you're going to plug into the formula. All right, so this one, number 2, is easy. They weren't asking you to figure out much. Yeah. Questions about this one? Okay. So here's your formulas again. Don't forget them. And here's your quiz. I'm only going to give you one problem because there's 3 parts to it. Okay. So let's take 10 minutes, do your best, and then we'll work this together. Okay. So a family has 150,000 bucks, a 30-year mortgage at 6.1% compounded monthly. Find the monthly payment, and then also find the unpaid balance after so many years. Okay. So first, let's find the monthly payment. Oh man, sorry about that. All right, so let's see. Let's use our knowledge of our formulas here. So this might not seem like an annuity, but whenever you have a loan taken out, basically it's like you're selling them an annuity. They bought an annuity from you. Okay. So we kind of have to think about these formulas a little backwards. So let's see, what do we want? 150,000. Is that going to be a present value or a future value? Pick our formulas here. We have PV equals PMT 1 minus 1 plus I to the minus N over I versus this one. So what's the 2 for it? Actually, we're about to learn about this stuff, but let's see if we could figure it out ahead of time. Then we'll do our, well, I guess we could read this because this kind of explains where it's going. This is an amortization. We're still using the same formula. The present value for an ordinary annuity has another important use. Suppose you borrow $5,000 from a bank to buy a car and agree to repay the loan in 36 equal monthly payments, including all interest due. If the bank charges 1% per month on the unpaid balance, how much should each payment be to retire the total debt, including interest, in 36 months? So actually, the bank has bought an annuity from you. The question is, if the bank pays you $5,000, that's the present value. So in our scenario, the bank is paying us $150,000, right? Because that's the amount of the loan. And we're paying them a payment per month, all right, for 36 months at 12% interest compounded monthly. What are the monthly payments? So this is basically what we're doing here. It's just a house instead of a car. All right. So the present value in this example is $5,000, right? And they want to figure out what the payments. The I and the N and the R and all that is easy to figure out. But we already have the formula. Okay. So up here, our present value is $150,000. That's how much the bank has invested in us. Usually the problems are like, we invest money in the bank, right? But we're kind of reversing roles here. The bank just invested in us, right? And we're paying the interest instead of us putting money in the bank and then the bank pays the interest. It's the exact same math, just the roles have been reversed. Does that make sense? Okay, so our present value is $150,000. The R here is 0.061. The 30-year mortgage, so T equals 30. Our I is the rate per period. Oh, we have to find out our period here. This is compounded monthly, making a monthly payment. Since those are both monthly, M is 12. So I is 0.061 over 12. N is the total number of periods or payments, which is number of payments per year times the number of years. So it's 12 months times 30 years, which is what? 360 total periods or payments, if you will. So if we use this dude, okay, again, this tells you whatever your payments are, if you've invested this amount and each month so the way we presented this formula was you put some money in the bank and then you're collecting interest on that money, but each month or each quarter or whatever, you're taking a little bit of that money out. So this is kind of the same thing, but the bank invested into us a present value, right? And each time we make a payment, it's basically like they're getting that payment, right? So it's the same thing. It's just who gave the money up front and who's paying the interest. Those roles are reversed. So here's our basic formula. We want to know what the payment is, right? Find the monthly payment. So the payment, basically we just divide both sides by this dude, right? And dividing by a fraction is the same as multiplying by its reciprocal. And we plug these in, we have $150,000. Our I is 0.061 divided by 12. 1 minus 1 plus 0.061 divided by 12. I ran out of room, so let's kind of like smash this over here. And this is to the negative 360th power. Now I have to plug this into a calculator. I should have done this earlier. Let's see. Anybody else can check my work by plugging it into their calculator? Let's see. 50,000 times 0.061 divided by 12 divided by 1 minus 1 plus parentheses. There we go. I'm getting approximately $908.99. So what you got? All right. That's the first thing. Now let's see. Look at this guy. What is the question? Find the unpaid balance after 10 years. Okay, so how we'd have to figure out how much of it we've paid off after 10 years, right? So let's see. We start off owing 150,000. How could we do this? We figure out how much we've paid in after 150,000, and then we subtract off what we've paid. This is a complex problem because the unpaid balance, that would include the interest, right? Because we're making payments. Let's see, as we're making payments, the interest is growing, right? So even though if we make, see, with 10 years, we make 120 payments, right? But that whole time, what we had was still collecting interest. This is tough. Anybody make any progress on this? The wrong formula. All right, let's look at, because this problem was out of the end of the chapter and it's a little bit past what we've covered. So let's come back to this. All right, let's look at an example and then we'll come back to this, dude. All right. So the book here, this is where we're at in the book, anyways. So we did this part, right? There's the car loan example. We just did that exact same part. All right. So in this example here, we're to pay off the car, we're paying $166.07 a month. So this is where we left off in our example. So after with this $5,000 loan, after 36 months, it has been amortized. All right, so that's what we're looking at now is amortization. It's the same formula from what we did in the last class. We're just using it differently. Okay, so amortize means killing the debt. All right, mort means death. All right, so we've killed the debt. That's where the term comes from. So this is the exact same formula we just used, right? Except it was PV equals, move this stuff over here, and we rearranged it to look like that. All right. So let's look at, oh, there we go. Look at this example 3. Let's do monthly payment and total interest on an amortized debt. Assume that you buy a TV for 800 bucks and agree to pay for it in 18 equal monthly payments at 1.5% interest per month on the unpaid balance. How much are our payments? Well, our payments, the formula we just used, right? We start off with this guy, but then we solve for payment. All right. And then we plug in our numbers, right? But we need to figure out what I and N are. So let's see, our present value is 800 bucks. Let's see, R 1.5%, that's 1.5, right? So it'd be 0.015. M, since this is monthly, is 12. That tells us that I, which is R over M, is 0.015 divided by 12. And N, the total number of periods or payments. So it's payments per year times the number of years. And that's what I forgot to write down was T here. T is, if it's 18 months, what is that? That's 1.5 years. So let's a little more in here. So M is 12 and T is 1.5. So this is 18. They told us that 18 monthly payments. That's the total. N is the total number of payments. Okay. So all we have to do now is plug in the numbers. We have 800 bucks. I is 0.015 divided by 12. 1 minus 1 plus 0.015 divided by 12 to the negative 18 power. Some of y'all might figure what this is. Like, I'd leave it as a fraction, right? If you turn it into a decimal, it might be a really long decimal, right? And if you round it, you're gonna have problems, because when you round that and you plug it in here and then raise it to the 18th power, that rounding gets compounded 18 times. And so your end result could be way off. So you want to leave this as a fraction and plug it into your calculator as a fraction so you get an accurate number. All right. Because some of these, like after 30 years, this is like to the 360th power. That's basically rounding something 360 times over and over and over and over again. It gets way, way off. Does that make sense? That might be why some of y'all are getting like the wrong answer. Okay. Don't do that. It's an important thing to learn, not just in science, but especially in business. You're messing with people's money. So let's see, we could plug this into a calculator, and it says $51.04 per month. So $51.04. That's what our payment's going to be. How much interest will you pay? Okay, well, this is where we have to solve for interest. Let's look and see what they do here. So yeah, not much of this is used in your calculus class next semester, but you do apparently use all of this in your business classes that you have to take. That's why they cover it in here. So the interest is going to be a simple subtraction, right? All you have to do is take the amount of all the payments and subtract the initial loans, right? The total amount paid minus the loan, and that's going to be your interest. So we made 18 payments of $51.04 on $800. So the difference is 118 bucks. So it's that easy to get the interest. We don't have to be like trying to solve for I or anything like that. Not in this example. Okay. Let's do a match problem here. See if we can figure this out. So I'm learning all this stuff with you as we go. Like I've never seen any of this stuff in my life. I do math. Y'all have to help me do the business here. If you sell your car to someone for 2,400 bucks, that sounds like a present value to me, and agree to finance it at 1% per month. All right, you got to be careful here. This is 1% per month. That means your interest rate is 12%, right? Or 0.12, right? Because R is your annual interest rate. Okay. What they're saying here is what your I is. This is your rate per period. They're saying that that is 1%. So they tell you what I is instead of R. So you have to be careful there in your interpretation, right? 1% per month. So they're telling you I. We probably won't need R, right? The formula uses I, not R in it. Okay. How much should you receive each month? So since it's monthly, that means M is 12. All right. And we need to finish in 24 months. So that's 2 years. N, they're telling us that N is 24. So they tell us what I is and they tell us what N is. Right. We're used to trying to have to figure that out from R and M and T, right? So they're telling us it's just what we need. How much interest will you receive? So we're the ones that are getting the interest, right? Because we sold our car. So it's just like the last problem, right? So we need to fit, what is it? Sell your car. So first we have to figure out what the payments are, right? So we can figure out just how much gets paid over the 24 months, because they're going to make 24 payments, and that's going to cover the 2,400 plus interest. So we need to figure out what the payments are and add those all up to figure out the total amount that they're giving us. So let's see. Where's our formula? Here's our formula. So same formula, the amortization formula. And we plug in our numbers. We got 2,400. I here is 0.01. and 1 minus 1 plus 0.01 to the negative 24 power. Now plug this into our calculator. These are hard for me to do because there's so many parentheses. 2400, and my vision is terrible. We got 0.01 divided by 1 minus 1.01 negative 24. All right, I'm getting $112.98. So what y'all got? All right. So the interest is the total paid. So that would be the payments times the number of payments, right? Minus the loan amount. That should be the interest. So let's see. 2.8. The hell. All right, I'm getting $311.52. Yeah. All right. Boom. Making progress here. We still don't know what we need to do. Need to know to do the quiz though. Let's see if we can explore and discuss. To purchase a home, a family plans to sign a mortgage $7,000 at 8% on the unpaid balance. Discuss the advantages and disadvantages of a 20-year mortgage as opposed to a 30-year mortgage. Include a comparison of monthly payments and total interest paid. I don't know. 30 years. I'll be dead in 30 years. That's one like comparison, you know. Come on. 20-year mortgage. I don't know if any of us are going to be able to afford to buy a house. Since the rest of the people here weren't even going to bother to vote. People don't vote, nobody's going to be able to afford anything. The billionaires are going to have all the money. That's just the way it is. Well, they have most of it, but if we keep doing what they want to do, they will have all of it, and they'll let all the poor people die off, and then they'll blow up the planet and live in their bunkers and think they're king of the world. Morons. Apparently Georgia, the Democrats won in Georgia. It's like 49% to 42%. It was just barely, you know. There are a lot of stupid people on this planet. Think of the dumbest person you've ever met and then multiply that by like 1 billion, and that's pretty much how dumb most people really are. All right, let's look at amortization schedule. Typically, it's just their people picker that's screwy. I have a lot of friends that are Republicans, a lot of them, and they're really great people, and I love them, you know. And they could rebuild the car engine from scratch. They could build anything. They could do all kinds of stuff. But when it comes to like their belief mechanism, they're just like, all that intelligence goes right out the window. They just believe whatever they want, and then they just look for evidence to fit whatever they already believe. Luckily, in the next section, whenever we get past this boring stuff, we're going to do logic, because we need logic to do statistics. And with statistics, you want to understand statistics. It's one of the most important types of math you can have, right? Because the numbers don't lie, but if you don't understand statistics, you can misinterpret it really easily. And the way not to do that is to understand logic. And that's where these people are lacking logic, basic logic. There's lots of biases that our brain has built in, and that's what's messing with them. It's not that they're mean or anything, they're just misguided. Amortization schedules. What happens if you are amortizing a debt with equal periodic payments and later decide to pay off the remainder of debt in one lump sum payment? This occurs each time a home with an outstanding mortgage is sold. In order to understand what happens in this situation, we must take a closer look at the amortization process. We begin with an example that allows us to examine the effect that each payment has on the debt. See, that's what we're gonna have to look at in our example, because they want to know how much is what left over after 10 years. Isn't that the question? Find the unpaid balance after 10 years. So that's what's kind of happening, right? Like say somebody buys a house, they pay on it 10 years, and then they lose their job, right? And so they have to, or they get sick and they don't have health care, right? You're screwed. So some other rich guy comes in and just buys off that house on the cheap based on what's left to pay off. And of course, since they have money, they don't have to pay any interest, because the poorer you are, the more interest you have to pay. So the poorer you are, the more everything costs. Okay. Thing with credit reports, right? You try to buy a car, right, or a house. You want to buy a house, well, they have to check your credit to figure out their interest rate. So anytime somebody checks your credit score goes down. So just by wanting to buy a house, when they check your credit to figure out the interest rate, your credit rate goes down, and thus your interest rate goes up. Yeah, or if you pay off your car, you think that would help, right? Your credit score. No, if you pay off your car, your account closes, and anytime an account closes, your credit score goes down, not up. If you pay off your credit card every month, so you don't pay any interest, you'll have a lower credit score than if you actually left some of it unpaid and paid interest on it, because they don't want somebody that they're not making interest on, right? You'll actually have a lower credit score. I still won't give them any money. I pay it off every month. But if you're trying to get your credit score to go up for some reason, you might lose just a little bit on there each month. So you're basically paying them to increase your credit score. Yeah. So it's rigged. That's why it's important to understand all this stuff inside and out, because they try to screw you around every single corner, right? So let's see. Look at an example here. Let's say we should just do all of it. Constructing an amortization schedule. If you borrow 500 bucks that you agree to repay in 6 equal monthly payments at 1% per month. So here's the thing right here. The 1% per month, that's what your I is, right? It's the rate per period. And they're not telling you R, they're telling you I. Okay, and it's 6 monthly payments. All right, so N is 6. N is the total number of payments or periods. All right, so they're telling you N here, not M. Okay, how much of each monthly payment is used for interest, and how much is used to reduce the unpaid balance? All right, this is a really important. All right, I have to look at this every time I pay off my student loans, because they ask me when I make a payment, how much do I want to go to the principal and how much do I want to go towards interest? Like they want me to decide. And I'm like, well, hell, I don't freaking know. You know, it's not like I'm ever going to pay this off ever. I'm going to be dead before I ever get this paid off, you know? So I just pick one. So let's see, we borrowed 500 bucks. So that's our present value. Okay. What's the first question here? How much, okay. How much is used for interest and how much is used to reduce the unpaid balance? So we're using our formula. We could figure out what our payment is, right? That's the first step. We just plug our numbers into our formula. We know what our payment is. So at the end of the first month, we look at the total interest. So if we're going to pay off the interest every month, I guess that's what they're assuming, that each month you're paying off all the interest that accrued. So at the end of the first month, before we made a payment, right? So the day we make a payment, we're charged $5. So clearly, even though at the end of the month we made our payment, they don't include that whenever they charge you interest, right? They charge you interest before you make that payment. All right, so we're paying $86.27. The day we pay that, they don't charge us interest on 500 minus that. They charge us interest on the full 500, because that's how much we had out the whole month, was that 500. All right, so there's $5 in interest. The amortization payment is divided into 2 parts: payment of the interest due and reduction of the unpaid balance. I'm interested to see how they figure this out. Because it seems like it could be a decision, like when I pay my student loans, they ask me. So here, there must be some assumption being made about what goes to what. So it's divided into two parts, payment of interest due and reduction of unpaid balance. Here's our monthly payment. So this is just for the first month though, right? Because on the second month, there's going to be a different amount of interest because there's going to be less money, right? That's been loaned out. So they take the interest. So we're assuming here that you're paying off all the interest each month. And then what's left over goes to paying off the balance. All right. Now my loans are so high, like I could make my maximum payment times 10 and it still isn't going to cover the interest. I think I have $25,000 in interest alone on my loans, my student loans. Yeah. That's what happens when you don't pay them for 10 years. All right, the unpaid balance for the next month. So we take the previous unpaid balance. This is how much. So we paid that much, but $5 went to interest. So this much goes towards the actual loan. So then the new unpaid balance is $418.73. All right, so that's what we have at the end of the first month. All right. I forgot what the question was. How much of each monthly payment is used for interest and how much is used to reduce the unpaid balance? Well, it depends on the month. That every month there's going to be a different amount of interest because every month there's a different amount that has been loaned out to you, right? So I'm trying to figure out what kind of question is that, right? So for the first month, there's $5 of interest because you had $500 out for the whole month. The second month, you're going to have $418. That's how much you owe them for that month. So the interest for that month is going to be a different amount, right? So to answer this question, how much of each monthly payment is used for interest and how much to reduce the unpaid balance? That depends on the month, right? It's different for each month. Let's see what do we have to answer for all, what, 6 months? Let's see. We continue. All right, at the end of the second month, this is what we had at the end of the first month. We get 1% interest. So the second month, we're paying $4.19 interest. But our monthly payment, which is the same every month, $86.27, right? We take away the $4.19, and so $82.08 is what's going towards what is left out of the $418. So we subtract that off from what was left of the loan at the end of the first month, and we're down to $366. This process continues until all payments have been made. That's right, I understand that. So to answer this question, for interest and how much is used, well, that depends on the month, right? Depends on the month. So to answer their question, you have to build a chart for all the months. So here is their answer. And if the quiz requires us to build a whole table, we're not doing it. All right. The quiz question is a little different though. It's not asking us per month. It says, find the unpaid balance after so many years, right? So that's just one, this is one number. It's not a whole chart of numbers. But I don't think we should have to build a chart in order to figure out what that number is. We're going to find out though, once we get to an example like that one. We're not doing match problem 4 because I don't want to build a chart. Boring. Not what I meant. In Table 1, notice that the last payment had increased by 3 cents in order to reduce the unpaid balance to 0. What? What increase? What are we talking about? The last payment had to be increased. Okay, so the payments from here to here, they increased it 3 cents. So the unpaid balance would be 0. So the last time, otherwise you'd have 3 cents on there for another month, and you pay 1% on that, right? So apparently whenever you get real close, they'll change your last payment. This small discrepancy is due to rounding the monthly payment and the entries in the interest column to 2 decimal places. All right, so the bank is actually keeping track of fractions of a cent, right? We round it every single time, right, to the nearest cent, right? Well, the bank keeps that. They round to their favor every single time. And whenever you do billions of transactions a day, and you're getting, a 100th of a cent, a billion times, you just made $1 billion just by rounding each cent in your favor. Okay. Suppose a family is making monthly payments on a home mortgage loan. If the family decides to borrow money to make home improvements, they might take out a home equity loan. The amount of the loan will depend on the equity in their home, defined as the current net market value. The amount that would be received if the home were sold, after subtracting all costs involved in selling the house, minus the unpaid loan balance. All right, there's a whole lot going on in that sentence here. The loan depends on how much the house is worth, which is defined as the current net market value, the amount that would be received if it were sold, but subtracting all costs involved in selling the house. All right. It's going to be a lot. I forget how much they charge now, like 6-7% just for your real estate agent. All right. Like a used car salesman, but way worse. Somebody who couldn't like figure out how to do anything else, so they just rely on their personality to rip off people selling one thing. If I could just sell this one thing this year, then I'm good. All right. I wish I only had to sell one thing. All I had to do was con one person out of their money once a year. That'd be my job. Instead I have to convince hundreds and hundreds of people to like mathematics every day. Talk about a task. All right, minus the unpaid loan balance. So equity, current net value minus unpaid loan balance. So this makes sense. That's why we need to know this stuff for our quiz, right? Let's say we've paid on our house for 10 years, right? And then we want to sell it, right? We need to figure out what it's worth on the market, and then subtract off how much the unpaid balance is in order for us to figure this out. Right here, our equity, right? Now we need this. The market tells us this is what we're trying to figure out. So after 10 years, after 24 years or whatever, this is what we're trying to figure out in our quiz here. Similarly, if a family decides to sell the home they own and buy a more expensive home, the equity in their home will be an important factor in determining the new home price that they can afford. I was looking at my dad's property, and we bought it for like 60 grand. Now it's worth like 800 grand. So the amount of taxes he's paid every year has added up to more than he actually paid for the property. So over 20 years, you think the mortgage is bad when you buy a house. Well, guess what? By the time you pay off your house, you're going to pay that 2 times over just in taxes from owning it. So you pay taxes when you buy it, and then you pay taxes every year just to have it. Meanwhile, billionaires don't pay any taxes because y'all won't vote. The young people just went out and vote. We could get rid of all the morons just like overnight. They'd just be gone. No more radical religious zealots running our country. People who have don't even have high school educations in Congress, mean, I know young people hate politics. Everybody hates politics. And they only hate politics because the government is riddled with morons because nobody votes. Right? We could make politics interesting and fun instead of something that's just absolutely horrible and miserable. Everybody voting out the morons. All right, let's see if we can figure out this equity in a home. A family purchased a home 10 years ago for 80,000 bucks. Sounds about right. The home was financed by paying 20% down and signing a 30-year mortgage at 9% on the unpaid balance. The net market value of the house is now 120,000. That's not realistic. 10 years, it only went up that much. Should be more like 500,000. The way prices have gone up today. My grandma's house we bought for 40 grand, and it's like $750,000, and the house itself is just going to be demolished. It's simply the 1 acre lot, right? So the 40 grand that he bought the house with, it was the land and the house, but the house is nice, but it's been 25 years and the house has not been taken care of. It's just a piece of crap. So it's gone from 40,000 to like 700,000, not including the value of the house, right? So if you took out the value of the house, the property would have been like half that, you know, like a $15,000 lot is now 700,000. Plus you have to consider the cost of demolishing the house for whoever buys it, right? All right, so eventually we will get to this section. Go through our steps then. All right, what was the question? How much equity does the family have in the house after making 120 payments? Again, it's a 30-year loan, so this would be after 10 years, right? 10 years. So that sounds a lot like our quiz, right? We need to figure out the equity after 10 years. And so if we know how much we paid into it, then we can subtract off how much we owe, right? And how much we owe is going to include interest, so it's not just the 150,000, right? One way to proceed would be to construct an amortization schedule, but this would require a table with 120 lines. Don't want to do that. That sucks, right? I mean, it wouldn't be hard to set up in like an Excel sheet. You just set up the formulas once, and then you just drag the right little corner on the cell down to 120 times. If you don't know how to use Excel, you need to start using it. If you're a business major, you should have been using that for years now, all right? So learn how to use it. It's important. Fortunately, there's an easier way. The unpaid balance after 120 payments is the amount of the loan that can be paid off with the remaining 240 monthly payments, the 20 remaining years on the loan. Okay. The unpaid balance is the loan that can be paid off with the remaining 20 years. So since the lending institution views a loan as an annuity that they bought from the family, the unpaid balance of a loan within remaining payments is the present value of that annuity and can be computed using Formula 5. So we use our same formula here. We have to figure out our payments. And that's what we did in the quiz, right? We found out what our payments were. So we've done the first step. So this is how much we pay per month over the whole, what is it, 30 years here to pay it off. So we did that in our quiz. So let's see what our step 2 is. All right, so here they're doing a 20-year annuity. So how much do they have to pay in for this thing after, if we make the payments for 20 years, how much would that present value be? How can I think of this? The present value of this much per month after 20 years, plug it into a formula, we have 57,000. So if we pay this much for 20 years, that's like if we had put in 57,000 today, all right? It's what the equality means, it's equivalent to. So $514 a month for 20 years with that interest rate is equivalent to paying off 57,250, whatever, $57,000 today, all right? So that's the unpaid loan balance. So if we use our formula here, go back to our quiz, let's just do A here. I'm not gonna do these. We have our payments. We need to do 10 years. So we're gonna figure out how much we've paid in. So we're gonna use this same guy. So our payments are 908.99. 1 minus 1 plus I is still 0.061 over 12. And instead of 360, what was this? It was monthly, and we're going for 10 years. So this would be 120 payments. All right. So let's see if I can type this in correctly. 908.99. Let's see if I plug this into the calculator correctly, I'm getting $81,506.70. Is that what y'all got? So this is how much we paid after 10 years. So that's how much we paid in. Okay. Now we want to find the unpaid balance. And I don't think we can just subtract this from 150,000 because the whole time there, I guess if we're assuming that we've paid off the interest every month, right? Again, that's not the case with my student loans. My payments aren't enough to even cover the interest that's accruing, right? So it can never get paid off, basically. Luckily, since I work for the government, or if you work for a nonprofit, after 10 years, they forgive the rest of your loan. But my payments are like $1,700 a month or something, half my income. So, where were we? So here's our unpaid loan balance. Well, no, I just wrote that's how much we paid off. This is the unpaid. Man, I'm misinterpreting this. The 20-year annuity. So what is this example? It's a 35-year loan. We pay off. What are they asking us? Find the unpaid loan balance after 10 years. What was it, a 30-year loan? So they do 20 years. Okay, so for us, actually, we need a different number here. So, that's not it. Where'd it go? That's not it either. Where is it? There it is. All right, so for us, it's a 30-year loan. The unpaid balance after 10 years, we need to change our M. No, yeah, our M is going to be 20 years, right? So our N is, because that's the years that aren't being paid, right? So it's 20 years that we're not paying. So instead of paid after 10 years, this is unpaid at 10 years. So we need the M to be 20. No, T is 20. 20 years, right? 20 years monthly payments. So that would be 240. This needs to be changed to 240 because it's 240 periods that we're not paying. All right. So we're using the formula to figure out how much that we wouldn't be paying, right? So this needs to be changed here. Everything else stays the same. So instead of looking at what we paid in 10 years, we're looking at how much we're not paying over 20 years, according to that example, which gives us $125,861.92. All right, that's our unpaid balance. Let's make sure we're understanding this correctly. This stuff is not easy. I mean, it's all just one formula, right? They like to make things as difficult as they possibly can with each formula. So let's read it. How can we find the unpaid balance after 10 years or 120 monthly payments? Forgot what this one is. It's a 30-year mortgage. They purchased it 10 years ago for $80,000. Okay. Instead of doing this whole chart thing, the unpaid balance after 120 payments is the amount of the loan that can be paid off with the remaining 240 payments. So that's what we looked at. The amount that could be paid off for the remaining 20 years or whatever it was in our example. Since the leading institutions use a loan as an annuity, so we can use our annuity formula. The unpaid balance of a loan within remaining payments is the present value of that annuity and can be computed using the formula. All right, so we found our payments and then we used their present value formula. So for the 20 years that they didn't pay, this is how much they need to pay. So even though it's a 30-year loan, after 10 years, we look at how much you'd have to pay for the following 20. And that's just step 2. I mean, we're done for our quiz. They didn't ask for us to find the equity. The equity, that's how much we paid in, right? So you have to look at the net market value minus the unpaid loan balance. We have the unpaid loan balance, right? That's the 20 years ahead of us. So they said that the value of the house is 120,000. So that's how much it's worth today. That's how much they owe. You subtract, and that's how you get your equity. Okay. So for our quiz, if we're going to extend this, we would have to be like, what is this? We'd have to know the present value of the house at 10 years. If they gave us that number, like what the house could sell for in 10 years, then we could figure out what the equity of the home would be in 10 years. Of course, we'll never remember any of this, but going through it and getting the gist of this stuff, if we ever had to do it again, we could probably figure it out, right? We'd have to go through all the same book and the same explanations and try to wrap our mind around it. So if you have to do it, which you'll probably have to do this in future business classes, probably in more detail. Okay, so this is just your first glimpse at this stuff. So don't freak out if, I hope this is the end of this section. We have, let's see, let's do problem. No, we're not doing a matched problem. I'm not doing that. It's way too boring. We still have 2 chapters ahead of us and another section in this chapter, I think. So we have example 6, example 7. Finally, the summary. All right, so next time we will do example 6 and example 7. hopefully finish this stupid chapter. Yeah, this is the last section in this chapter. Then we do 4.4. I hope it's something cool. Chapter 7 and 8 are awesome because they're just math. Yes. Mainly statistics and stuff, which this is what they should teach us in high school. It's more important than calculus. Of course, you need algebra to do statistics, though. But to do real cool statistics, you do need calculus. But the basic statistics is something they should start teaching us in elementary school, because that's where you get your basic logic and how to break things up and really understand the world around you. Right? So that's where we're going to go next. For the exam today, as long as you turn in the quiz, all right, as long as you turn in your quiz, all right, by midnight, you will give all of those people full credit on the exam. If you don't turn in the quiz, if you don't turn in the quiz today, you're getting a 0 on the exam, even though there's no exam. That's the exam. All right. So daily exam number 23, number 1, turn in today's quiz for full credit on this exam. Otherwise, you get a 0. Da-na-na-na, na-na, na-na. All right, let's get out of here, folks.